today is the 5th lecture on solid state, which is CBSE class 12 chemistry, very first chapter. So what we are going to learn today is unit cell, types of unit cell and arrangement of the constituent particle in those unit cell. So let's have a look in the presentation. Okay, so let's start. This is the picture of unit cell and arrangement of unit cell. What we get is a crystal lattice. This I have discussed in previous lecture also. Unit cell is that smallest portion of entire crystal which is evenly propagated in all direction to make an entire crystal. And we suppose unit cell is a cubic structure. So the cube has vertices, and these vertices are actually called lattice point, and they are occupied by atoms or ions or molecules. Those all are called constituent particle of a crystal lattice. So crystal lattice is a regular repetition of unit cell throughout in all possible direction, and the lattice points of a unit cell are occupied by the constituent particle. So let's move to the next topic. Unit cell is basically categorized in two types. First, primitive unit cell. It is also termed as simple unit cell. Simple unit cell, as I show you that unit cell you have to imagine as a cube, and cube has 8 vertices. If the constituent particle of a crystal occupy only the vertices of a unit cell, we termed as a primitive unit cell. In spite of occupying the vertices, if atoms also occupy other spaces available in a unit cell, we termed it as a centered unit cell. Okay? So let's have a look of a primitive or a simple unit cell. So this is a cubic structure, and these all are vertices, right? And the vertices are occupied by the constituent particle. Remember, only vertices will be occupied in a primitive unit cell or simple unit cell. So this way you can get a 3D imagination. So students, you have to imagine, you have to use your visualization power. So this is like a box where all the vertices are occupied by the constituent particle, and this is primitive unit cell. Next, body centered. In a body centered, what I said to you, along with the vertices, constituent particle will occupy some other positions, other spaces in a unit cell. The first example is body centered unit cell. In short, we termed it as BCC also. So in BCC, what you say, all the red balls are the vertex position which are occupied. After occupying them, this is the middle portion of the cubic unit cell which is also occupied. That is the center of entire body of unit cell. This is called body centered unit cell. Next, in a centered unit cell, next criteria is face centered unit cell. It is also termed as FCC. So in FCC, after occupying the vertices, it occupies all the center position of the faces. Look this diagram or the model very carefully. At the center of the faces, the atom have occupied after occupying all the vertices. So this is also termed as FCC. Next is end centered unit cell. The simple or the short name is ECC, end centered unit cell. Here is an exceptional arrangement of atoms that after occupying the vertices, see, these are the vertices which are occupied by the constituent particle. They will occupy center of any two opposite face. See, I have here shown two positions, top and bottom. It may happen they can be at left and right position, but they will only present at any two opposite faces only, not in all faces, whereas in FCC all the faces are occupied. So next thing is that let's have a look in NCERT. In NCERT also same thing is written what I just shown you. As NCERT is important, we should know that unit cell is of two types, primitive and centered unit cell. Primitive, where the constituent particles are only present at the corner, and in centered the constituent particles are present at corner in addition to those other corners also. That means after occupying the corner, other spaces also. It is also categorized in first body center, short term is BCC, second is FCC, and after that end CC. So this four types are, one is primitive, and in centered unit cell three categories. So totally four ways are there to arrange the constituent particles in a unit cell. Okay, now the unit cell can have 7 different criteria. How? So in the last lecture I have told you, in a unit cell there are 6 different parameters are available. A, B, C. These are the arm length of my cube, and then is alpha, beta and gamma. Alpha, beta, gamma are the angles between any two arms. As I told you, it as a trick in a last lecture, angle between A and B will be gamma, angle between B and C will be alpha, and angle between A and C, it will be beta. Fine. Now we are considering cube unit cell. We are considering what? As a cube. In cube we all know all the arm length are equal, as well as all angle will be equal to 90 degree. So this is the first possible values of all the 6 parameters. If we get this values, then the structure of my unit cell will be like this. Now if I change the angles, like here in this example, alpha, beta and gamma, all angles are what? They all are less than 90 degree. In another word, what I can say, none of the angles are equal to 90 degree. So none of the angles are equal to 90 degree. Even arm lengths are also not equal. B is smaller than A is smaller than C. So changing this parameter, we are getting different form of unit cell. So now comes another point, that a unit cell can have different possible structures also based on different value of this parameter. So let's see. So this is 7 possible structure of unit cell based on different parameter. See here, alpha, beta, gamma, all angles are what? All angles are 90 degree. All angles are 90 degree, and A, B, C all are equal. That's why this is termed as cubic. If I change parameter, like I am not changing angle, I have changed the arm length. A is equal to B, but B is not equal to C. Then the structure of unit cell we get, it's tetragonal. Similarly, again if we change only the arm lengths where all arms are different but angle is same, it forms orthorhombic structure unit cell. If alpha beta is equal but angle is 120 degree for gamma, even A is equal to B but none of them, A or B, none of them is equal to C, the structure that we obtain for a unit cell is a hexagonal. Similarly, there is for rhombohedral. You can see all angles are for alpha, beta, gamma, all are more than 90 degree. That means none of them are equal to 90 degree. Even in case of arms are equal, but angle is not equal. That's why it is termed rhombohedral. Next is monoclinic. In monoclinic, again there is a problem of angle. Alpha and beta are 90 degree. Sorry, alpha and gamma is 90 degree, but beta is not 90 degree. Like in hexagonal, alpha beta 90 degree, but gamma is not 90 degree. It is actually 120 degree. So here alpha beta same, beta is different. So it is monoclinic. And last is triclinic. So in this way, on changing values of parameter, all those 6 parameter, we can get 7 crystal system. You can imagine it as a box. These are different shapes box where you have to arrange the constituent particle of any ionic solid or ionic crystal. I hope this much is clear. Next from here, see what I saw, there are 7 different boxes are available with different edge length or angle between them. These boxes are termed as crystal system. It is also mentioned in NCERT. See, this is our NCERT. These are 7 different possible crystal system. Now, we have to arrange atoms or the constant particle in them. After arranging all the constant particle in this 7 different type of crystal system, total possible arrangement are there 14, and this 14 is termed as Bravais lattice. So this table is very important, students, for CBSE as well as for the joint. Sometimes there are directly asked question from this table only. So this is first crystal system is cube. Cube is what? This is my box whose all angles are 90 degree and all edges are equal. So this is my box which is cubic. Now in this box I can arrange atom in 3 different ways. Primitive, only at the corner, body center, after at the corner, at the center of the body, face center. After adding the constant particle at the corner, we can add constant particle at the center of the face also. So the example is very important. NaCl, zinc blende and copper, very important. Tetragonal, again the shape will be different. How will be the shape? Here. This is the shape of the tetragonal. For tetragonal shape kind of box or the crystal system, we have 2 ways to arrange the constant particle. An example here is there. Similarly, orthorhombic. Actually, this is very important. The question that were asked that from orthorhombic, what are the possible ways of arrangement of atoms? Or they can ask examples directly. And this is hexagonal. An example is graphite, ZnO, CDS, and then is rhombohedral, trigonal, and the example is calcite, HGS, cinnabar. Calcite is CaCO3. See, this is the parameters. My dear student, this is very important table. And after all this arrangement, how many possible structures are there? See, there are 14. If my parameters all are equal to each other, then it is cubic. Then the way that I can arrange the constituent particle, primitive, body centered, face centered. Similarly, if alpha, beta, gamma is 90 degree, but A equal to B but not equal to C, then my box or the crystal system will be called tetragonal. And in that case, the possible way of arranging the constituent particle is available only primitive and body center. So now you count. This is 7 kind of crystal system. Crystal system is the box where you have to put the constituent particles. In every box there are different ways of arranging atoms are available. So total number of arrangement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this 14 is termed as Bravais lattice. So this is all for today. If you have any doubt, then please write it in a comment box. For the previous chapters or the lectures, link is given in the description box, or you can click simply I button for the playlist. If you like it, please hit the like button, hit the bell, and also subscribe to my channel. Thank you very much for watching Reaction Tube.